Hello everyone, my name is Karan Mashru. Welcome to this video. So in this video, we are going to look at the solution of the problem, that is modified game of name. First of all, let us start by understanding the question. What does question say? You are given an array A of n elements. There are two players, player 1 and player 2. So there are two players and we have an array A of n elements. A player can choose any of element from an array and remove it. Okay, so in one move, player can choose any of the element from array and remove it. If the bitwise XOR of all the remaining elements equals to 0 after removal of the selected element, then that player loses. So basically, if there are, let's say, k number of elements at present and player 1 removes an element, and if the XOR of the remaining k minus 1 elements becomes 0, then that player loses who last picked the element. Okay. Find out the winner if player 1 starts the game and they both play their best. So player 1 will start and they will give their best. Okay, they will play optimally. For example, here the second player is a winner. Why? Because let's say if the first player picks 3, then the remaining is 2 and 3. Their XOR is not 0. So game is not over. Then player 2 picks up either 3 or 2. So remaining will be 1 element. Then player 1 again picks up the last element and then the set becomes empty. So the XOR is 0. So player 1 loses and 2 wins. Okay. Here player 1 wins. Why? Because the XOR is already 0. Okay. So when it's already 0, so player 1 is winning the game. Okay. Since the XOR of an array is already 0, player 1 wins. You do not need to read input or print anything. Your task is to complete the function findWinner, which takes the number n and the array A as input parameters and returns an integer denoting the winner. The expected time complexity is big O of n and expected auxiliary space is constant. So now if we think about solving this problem, so basically see, we have an array A which contains n elements and two players are playing a game, player 1 and player 2. They both give their best, okay? And player 1 starts the game and then the turns are alternative. So 1, 2, 1, 2 and so on. Now, let's say these are the n elements of the array. If the XOR of all the elements is already 0, then in that case, player 1 wins the game, okay? If the XOR is not 0, then whenever whichever player turn is there, they can remove any element from the array. So let's say player 1 removed this element. Now, if the XOR of the remaining elements becomes 0, then the player who last made the move loses. So player 1 will lose. But if the XOR of the remaining element is not 0, then the player 2 gets the chance to play. Now let's say player 2 removed this element. Player 2 also can remove any element. Now if the XOR of the remaining elements becomes 0, then in that case player 2 loses because player 2 made the last move and player 1 wins. So this game continues until at some point of time XOR of the remaining elements becomes 0, then the last player who made the move loses. Or if the array becomes empty, in that case also we believe that the XOR of the remaining elements is 0. So the last player who removed the element will lose, okay, and the other player will win. So now we need to tell, given an array of n elements and two players 1 and 2, we need to return the integer of the player who will win. If 1 will win, we will return 1. If 2 will win, we will return 2. Now see, we cannot solve, one of the ways will be to solve it brute force. Okay, so by brute force, what we need to do is recursively call all possibilities. So let's say player 1 remove this or 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 this. So we will call all the recursions. Then in that further, there will be a lot of recursion. So there will be a lot of cases and the time complexity will be very high and it will give time limit exceeded. So we need to think of something more efficient. So what we will do is we will take small examples and try to build it up and try to get some pattern or something and solve the question. Okay. Let's say n is 1. There is only one element. Okay. So now also let's divide all the cases into two parts. One, if the XOR of the initial array, if the XOR of the initial array is 0, okay, so let me write it like this. If the XOR initial is 0 or it is not 0, okay. If the XOR initial is 0, then already player 1, there is nothing to do because player 1 only cannot make the move. So player 1 will win, okay. If the XOR is not 0, we are discussing different cases. Let's say there is only one element. Now XOR is not 0. This is the case where XOR is not 0, right? So there is some element here. Now player 1 can make the move. But as soon as player 1 will make the move, the array will become empty and we will consider it XOR to be 0. So who will win here? Player 2 will win. Okay, so player 2 will win. Okay, now let's say n equals to 2. Okay, initial XOR is not 0. Okay, XOR of all the elements. Initial XOR means XOR of all the elements, right? If n equals to 2 and the initial XOR is not 0, it means these two elements are different. See, if the initial XOR is same, both the elements must be same. So 7 XOR 7 will be 0 or 9 XOR 9 will be 0. But if the initial XOR is non-zero, it means both the elements are different. So let's say 9 XOR 8 will be equal to what? 1. Are you getting my point? So these elements are different. Let's say player 1 removed this element or this element. Let's take any, they removed this element. Now player 2 has only one element, but is the XOR of the remaining element 0? No. Why? Because this element was different than this. A single element will not give you XOR 0. So there is no choice, but player 2 will remove this element. As soon as player 2 removes this element, the array becomes empty and we consider the XOR of the remaining elements to be 0. So player 2 loses, so player 1 wins. Now let's take the third case where n equals to 3. Okay. Here there are 3 elements. Okay. Now player 1 takes the first move and the XOR of the initial array configuration is not 0, right? Because if it's 0, it comes under this case. If it is not 0, then we are discussing different cases. Now, if player 1 removes an element such that the XOR of the remaining elements becomes 0. See, there are 2 cases. Okay. So let me make it like this. 2, 2, 3. Okay. If player 1 removes an element such that the XOR of the remaining elements is 0, because if player 1 removes 3, XOR of the remaining array is 2, XOR 2 is 0, then player 1 will lose. If player 1 removes an element such that XOR of the remaining array is 0, then player 1 will lose, obviously. So player 1 will not do that. What will player 1 prefer? It will prefer to remove an element such that XOR of the remaining element is not 0. So in this example, it was possible to remove an element such that XOR of the remaining elements is 0. In some example, it might not be possible. Let's say you have 3 elements, 1, 2 and 4. You remove any element, XOR of the remaining element will not be 0, right? But player will not choose an element to remove such that the XOR of remaining element will be 0. Otherwise, that player will lose. So player 1 will, for this example, will either remove this or this. For this example, it removes any one, it doesn't make a difference. Let's say player 1 removed this element. Okay. Now, this example got converted to this example. 2 elements are remaining, and XOR is not 0, and XOR is not 0, right? Here player 1 was winning because 1 was starting the game. Here, now for the remaining array, 2 will be playing first because 1 already removed this element. So now player 2 will be playing first. So for this, if player 1 is winning, for this player 2 will win because now this is same as this. It's just that now player 2 has the turn. Okay. Now n equals to 4. Again, there will be 4 elements. Now player 1 initial XOR is not 0. Okay. Let it be A, B, C, D. If there is an element such that if player 1 removes it and the XOR of the remaining array becomes 0, if player 1 will remove that, then the XOR will become 0. So player 1 will lose. So player 1 will not do that. So player 1 will remove an element such that the XOR of the remaining array elements is not 0. Are you getting my point? So if player 1 removes an element such that XOR of the remaining elements is not 0. So let's say player 1 removed this. Okay. So now this remaining basically got converted into this complete case where the elements are 3 and the XOR is not 0. Here for the complete example, okay, I'm not talking about 2 elements. It became equivalent to this example, n equals to 3 and XOR is not 0. Here for the complete example, first turn was of player 1 and player 2 was winning in any case. Here for this remaining part, which is same as this, player 2 is taking first chance, so player 1 will win. Here player 1 was taking first chance, so 2 was winning in any condition. Here for the remaining case, which is same as this, player 2 is taking the chance, so player 1 should win. So in this case, player 1 will win. So what is the pattern we are getting? If the initial XOR is 0, player 1 will win. If the initial XOR is not 0, if array is odd, player 2 will win. If array is even, player 1 will win, and so on. Okay, such a way. Now implementation is quite simple, but let's have a look at it once. Okay, so let's have a look at the implementation. So I have taken one variable x to store the XOR of all the elements. Okay, XOR of the initial array. So I have done x equal to x XOR I. If x is 0, directly return 1. Then if initial XOR is not 0, if n is odd, then player 2 will win. If n is even, player 1 will win. Right? What will be the time complexity? It will be big O of n, because we are running one for loop to calculate x. And what will be the auxiliary space? The auxiliary space will be constant, because we are only using some few variables. Now let's submit this code. Okay, so let's submit it. Okay, so we have solved this question successfully. I hope you understood the solution completely. Thank you.